So today we're doing values for inverse trig functions, and you have different values depending on which angles you're plugging into the function. But we had gone through our do now and noticed, well, hopefully we noticed, we noticed that a function and its inverse are closely related to each other. So with that being said, we need to know the function values for trig functions before knowing the values for inverse trig functions. Hopefully that made sense. It sounded a lot of different words with the word function in it and the word trig, but you'll see what I mean. So yesterday we looked at the curves for sine and cosine and even a little bit of tangent. And we could kind of use that to fill out this table, but only part of it because we saw what was going on from 0 to 2 pi or almost. If you're not sure, you can always put it into your graphing calculator and see. And then we have pi over 6, pi over 4, and pi over 3. We went over last term and now this term. You need to know these angles in radians. So although I'm going to say it now, you need to know that pi over 6 is the same as 30 degrees, okay, without conversion. Pi over 4 is like 45 degrees, and pi over 3 is 60 degrees. In order to find those particular angles, okay, you need your special right triangles. The other ones are actually called your quadrantal angles. So I actually answered that question there in the example, but I want to show a graph with those angles involved, or at least the coordinate plane where the angles lie. So I'll get to that later. All right, so first thing is this table that we're going to fill out. And so we have sine of 0. If you look at our graph, our first point we usually plot is at the origin for sine. So basically, if you plug in 0 for x, we're getting 0. If we plug in pi over 2, okay, we would be getting 1. That is because our graph goes up to a y value of 1. Then it touches the x-axis again, and then it goes down to -1. So sine of 3 pi over 2 is -1, and then it goes back to the x-axis. So sine of 2 pi is 0. Okay, we'll just stick with the quadrantal angles right now because we're talking about the curves that we saw. I'm going to do like sad drawings here. I was talking about the sine curve. Now we'll talk about cosine. Here we go. So it starts at 0, 1. So cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0, and cosine of 2 pi is 1. Tangent. All right, so we spoke about vertical asymptotes, and the first one, where x was positive, was at pi over 2. So we really don't have an answer here. I'm going to put like an x. Put not applicable, it's not defined, or just kind of cross it out. The next one is actually at 3 pi over 2. I did plot a point at the origin, so the tangent of 0 is 0. And I did a point at 1, 1, but that was for when x was pi over 4. Okay? So we don't have an answer for pi over 2, but we do have for pi over 4. And now pi is at 0 again. And at 2 pi, it's also 0 if we kept going. Okay. So now, our special right triangles are going to answer the other angles. So I'm going to erase these drawings. And I'm going to draw the special right triangles. We usually draw the special right triangles just in the first quadrant so that we can look at positive values. It's easier to look at the positive values to evaluate. So across, there's theta, there is our right angle. We actually put in some angles here. So this is 90. We do not evaluate 90 degrees, which is pi over 2, from our special right triangles. So we do evaluate pi over 6, pi over 3, and pi over 4 from our special right triangles. Okay? And this is what develops the unit circle as we go around all 4 quadrants. So if you're familiar with the unit circle, you can check your values to what we did already and what we're going to put in. So across from pi over 6 is 1. Okay? Across from pi over 3 is radical 3, and our hypotenuse is 2. Across from pi over 4 is 1, there we go again, and the hypotenuse is radical 2. Okay, so sine, SOHCAHTOA. Sine is opposite over hypotenuse, so sine of pi over 6 is opposite over hypotenuse. It becomes 1/2. Sine of pi over 4, opposite over hypotenuse, becomes 1 over radical 2. Which you also should know this as, let me erase this. It's rational inversion, which is radical 2 over 2. Okay, sine of pi over 3, opposite over hypotenuse is radical 3 over 2. Squeezing that in there. Hopefully you heard me so you can actually write it down. So now let's do cosine. Cosine is adjacent over hypotenuse. So if we're doing adjacent over hypotenuse, let me fix that 6 there. For cosine of pi over 6, it's going to be radical 3 over 2. Again, hopefully you heard me because I squeezed that in there. For pi over 4, even though we're doing adjacent over hypotenuse, once we do that, then we end up with the same answer as we did for sine. So I'm just going to draw an arrow down. You have to remember it's 1 over radical 2 or radical 2 over 2. Now for pi over 3, the cosine of pi over 3, if we do adjacent, sorry, let's take that out. Adjacent over hypotenuse, this is going to be 1/2. I can squeeze that in there. Okay, I think we could see that a little bit clearer. So now tangent. Tangent is opposite over adjacent. So if we were to do tangent for pi over 6, we're going to do opposite over adjacent, so it's 1 over radical 3. You also must know this one as radical 3 over 3. Okay, we already did tangent of pi over 4. Okay, the tangent of pi over 4, since it's opposite over adjacent, it's 1 over 1, and that's why the answer is 1, which we already established. And tangent of pi over 3, if we do opposite over adjacent, we get radical 3 over 1, which is just radical 3. Okay, and there we have it. So our table is filled out, and we're going to talk about our quadrantal angles. So you must know these. I tell my students, some students memorize the unit circle already. And I'm like, okay, good, you can use that. Some students have to kind of draw out the triangles and figure them out on their own. That's fine too. And some students just really memorize this table. And if you memorize this table, that's fine. Whatever will work best for you. If you can memorize it and you have to work it out, that is fine. Okay, so the quadrantal angles. I just want to refer to when you draw out the coordinate plane, your values are what continue. Okay, so I'm not going to put actual arrows here. I meant like your values for x and y. When you label your angles, they don't change. They're not going to get bigger or smaller, so you don't need arrows for that. This is 0 radians. This is pi over 2 radians, okay? If theta becomes this large. And if I keep going, and it's always counterclockwise, this is going to be pi. And if I keep going, this is 3 pi over 2. If I come all the way around, your angle measure is 2 pi. And we could keep going. We don't have to. Okay? Hopefully at that point, we get the idea of where your quadrantal angles fall. It's also important to note that, as was mentioned earlier, this is theta. You have to draw your right triangle in. Okay, theta is always closest to the origin. Think theta, you're kind of drawing a circle, so it should be near where you would put a 0, which is also a circle shape. Okay, and those are your right angles. It kind of looks like a butterfly. So in this happy, cheerful moment, I'm going to now say, not only you need to know these answers forwards, but just like a lot of things, you need to know things forwards and backwards. So if you know the function values, you should be able to know the values for the inverse trig functions. So for example, we're going to do A, arc sine of radical 2 over 2. What that is really saying, you don't have to copy it, but I put it here so you could kind of read it. You need to find the angle, so think arc is saying A, angle. Find the angle in radians such that the sine of that angle equals radical 2 over 2. So we're finding the angle. And so A for angle. It's not always going to be arc sine or arc cosine or arc tangent. It could just say inverse. That's the same thing that we're doing. We're doing the inverse. So you have to know it both ways. All right, with that being said, let's go back to part A. So we see that the answer here is a positive radical 2 over 2. Okay, so for a positive radical 2 over 2, we end up looking at our table and it's almost obvious, okay, that the angle would be pi over 4. The answer is pi over 4, but it may not be the only angle. If you're working in this kind of scenario with your quadrantal angles, all 4 quadrants, it's not the only answer, okay? So I'm going to go over something with you. Sine is positive not only in the first quadrant where all the trig functions are positive, but in the second quadrant too. So you should know this. All students take calculus or however you memorize this. And that's important because then you know the angle measures and what you should do with them. So you think of this as your reference angle, theta. And so you add it to 0 or you subtract it from pi, or you add it to pi, or you subtract it from 2 pi. And that would give you more than one answer for this problem. So, not only is pi over 4 our answer for part A, but if you were to subtract this from pi, then you get 3 pi over 4. Both answers would work. The sine of 3 pi over 4 and pi over 4 are both radical 2 over 2. Okay, next one. So cosine is negative here. Okay, so let's worry about not that it's negative, but that the answer is 1/2. So cosine is 1/2 over here. I actually wrote it in black. So cosine of pi over 3 is 1/2. So your reference angle, theta, is pi over 3. Okay, where is cosine negative? Cosine is negative, Okay, in the second and third quadrants, it's first and fourth cosines positive. So second and third quadrants is where we subtract pi over 3 from pi and add pi over 3 with pi. So that's going to give us our angles. So it's going to be 2 pi over 3 and 4 pi over 3. So the cosine of 2 pi over 3 and 4 pi over 3 give us an answer of negative 1/2. So both of these are our answer. C. Okay. Tangent, radical 3 over 3. So we said this before. You must know 1 over radical 3 is radical 3 over 3. And that refers to, so reference angle, theta, is pi over 6. It refers to pi over 6. So tangent is negative in quadrants 2 and 4. So quadrant 2, we have to subtract pi over 6 from pi, and in quadrant 4, we have to subtract it from 2 pi. So I'm squeezing in the answers. You know what, I'll just write them here. So that gives us answers of 5 pi over 6 and 11 pi over 6. Okay, yes, you have to know how to combine and make common denominators if you're not used to that already. So take your time and make sure that this makes sense. But yes, essentially the tangent of 5 pi over 6 and 11 pi over 6 both give you negative radical 3 over 3. So you have to know the backwards and forwards, and then you will be done. So good luck.